independent sources are nothing but these are the sources which can have the energy of its own. We are going to call it as the independent source. We are going to call. So the voltage source will be denoted like this. So this is the voltage source will be denoted. So with the plus and the minus, this is a positive and this is a negative. We are going to call it as independent voltage source. And similar way we can denote it with the symbol like this. This is a symbol of the battery. This is the plus and the minus. So it is going to be denoted with the voltage V is a unit for the volts here, and the V is the voltage unit for the voltage. So these are the independent sources which is having the energy of its own. It is called as a independent source we are going to call. So similarly for the AC voltage source, so if I'm having the AC voltage source, that will be denoted with the symbol called the sinusoidal symbol we are going to denote, and it will be denoted like this V. So usually it is having the frequency will be there. So we can call it as a Vm sine. Usually it will be denoted as a omega t, where omega, but it is a 2 pi f. F is the frequency content of the this AC voltage source, and the unit for this one will be the V we are going to consider, and Vm is the maximum RMS value for the voltage. You are going to call it as a VM you are going to call. So this is for the voltage DC voltage sources and the AC voltage source. So similarly, let us look into for the current source. So let us look at the current source. The current source is having the polarity. So you're going to denote like this. So the arrow denotes it's a positive end, and the tail denotes the negative end. The unit for the current is nothing but amps you're going to denote. So this is for the current source we are going to denote. So it may be applicable for the whether it may be the independent or it may be the DC or the AC. We are going to use the same notation we are going to use in order to represent the current present in the circuit element. So this is how the current source will be denoted, and we have these are the independent sources which have the. So similarly we have the another kind of sources we are going to call it as a dependent source we are going to call. So another kind of source which is called as the dependent sources we are going to call. So this is the dependent sources. So these dependent sources are the sources in which it does not have any energy, but the energy of this one depends on the energy of the somewhere in the circuit elements it is depend here. For example, assume that the depending on the voltage across the resistance, the voltage or the current of the source is depend. That one you're going to call it as a voltage dependent voltage source we are going to call. So these dependent sources in which the voltage will be dependent on the somewhere in the circuit elements here. So there are some four different kinds of four types of the dependent sources are there. Four types of dependent sources, and the dependent sources are denoted with the symbol. The symbol for the dependent source will be equal to the. So you're going to use the diamond shape you're going to use, whether it may be the current or the voltage source. For the independent one, you're going to use a circle. For the dependent one, you're going to use a diamond shape. So we have the four different types are there. The first type of voltage source is nothing but it's a voltage controlled voltage source. So it is the controlled voltage source, voltage controlled voltage source, and the next one is the current controlled voltage source, current controlled voltage source. So I'll explain the each and every one. Next one is the voltage controlled current source, voltage controlled current source, and the next one is the current controlled current source, current controlled current source. So these are the four different types of the dependent sources. For is the independent source. So I'm not going to worry about the independent source, and I'm having the source in which the dependent source it is going to be indicated like this, and this is the circuit elements, and assume the some more circuit elements are present here, which is connected like this, and this is assume some the dependent voltage source is there, and this is the some resistance R, and this is some resistance R1, R2, R3, R4, and R5. So this is the dependent source we have. Now, based on the different types of dependent sources, I'm going to explain the concept. So it is a voltage controlled voltage source. So voltage source is nothing but the type of the dependent source is voltage source. So I'm going to denote this one with the I'm going to denote this one with the symbol called as the plus minus, or we can denote as a minus plus also we can denote here. So this is the voltage source here, in which the voltage of this one is depends on the voltage across somewhere in the circuit element here. For example, assume that the voltage across this one is something called VR here, voltage across the VR1. So the voltage of this one depends on the voltage across the resistors R1. So we are going to call that type of source as a voltage controlled voltage source, because based on this voltage, the voltage source of this one is depend here. So let me denote this one as a, so A into something called VR1 I'm going to denote here. So A may be the certain scaling factor, and VR1 is the voltage across this one here. So to be recall, so the voltage of this one, this is a voltage source. The voltage of this one depends upon the voltage across the resistance R1. So that's why you're going to call it as a voltage controlled voltage source we are going to call here. Okay, so this is a kind of the source. This is the voltage source, and the voltage of this one depends on the voltage across somewhere in the circuit element. We are going to call it as a voltage controlled voltage source. So similarly, I'm going to consider this part of the network in order to explain this one. I'm going to take the circuit elements here. The second case is nothing but the voltage controlled current controlled voltage source. For example, assume that, so as the name indicates, this type of the source is voltage source. I'm going to write the symbol as, so this is a symbol for the second one. So this is the first one, voltage controlled. This is current controlled. This is 2, 3, 4. So for the second one, the type of the source is nothing but it's a voltage source. So the symbol will be positive and minus. The current control voltage source means the voltage of this one this depends on the, say this is nothing but the dependent source. The voltage of this one depends upon the current in the somewhere else in the circuit diagram. For example, assume that the current through this one is nothing but, I am going to call it as IR5. So the voltage of this one depends on the current to the circuit element R5. So we can denote this one as a B into IR5 we can denote here. So it means that for the voltage source, the voltage depends on the current in the circuit element, which is called as a R5. So this is called as a voltage controlled current source we can call here. Sorry, current controlled voltage source we can call here, because through depending on the current, the voltage of this one is dependent. That's why it is called controlled, or the current dependent voltage source we can call here. Even controlled is also called as a dependent we can call here, or it may be the controlled we can call. And let us look into some third type of circuit, which is called as a voltage controlled current source. Means the type of the source is nothing but it's a current source. The type of the source which is called as a current source here. So I can denote the symbol for the current source. We can denote like this. And the symbol for the current is nothing but this one. The current source, the value for the current, I can call it as a ID. It depends on the voltage across somewhere in the circuit element. Say we taken VR1, we are taken something. I'm going to take the voltage across this one is called something VR4. I'm going to consider VR4. So for the current source, the voltage across the resistance R4 is depend. So I can denote this current VR4 we can depend. So it's voltage dependent current source, or it is also called as a voltage controlled current source here. The current of this one depends on the voltage across the resistance R4. So that is, it is called as a voltage current source. Now let us, this is the third one. Now let us consider the fourth type of circuit element, which is called as a current controlled current source. So the type of the source is nothing but it's a current source. It's a current source. Say something called ID is the dependent current source. So the current of this one depends on the current through the any other circuit elements. Let us say through the, we call the current as IR3 we can call here. So this is IR3 we can call. So based on this current, the current of the current source is depend. So we can call this as a something called D into IR3. We can call this one as a, so current dependent current source, or current controlled current source we can call. So these are the different types of the sources, the practical sources where we are going to use in the circuit elements. So usually in the network reduction techniques, easily we can remove the voltage source, we can remove it here, but it is not possible to remove the dependent sources. The independent sources we can change here. The dependent sources it is not possible to change. But in case of the source transformation, even we can perform the source transformation for the dependent as well as for the independent sources. Equally we can apply. And also for the independent sources, there are two different types of independent sources are there. One is called as a practical sources, other one is called as a ideal sources we are going to call. So for the dependent sources, we have the two different types of sources are there. So one is called as the practical sources, other one is the ideal sources we are going to call. So first let me consider the ideal sources. Let me consider where ideal source is nothing but the voltage of the circuit. So let us say this is the voltage which is having the voltage V. The voltage, so let us say I'm going to measure the voltage V1 here. It will remains constant throughout for the entire duration. It is going to remains constant here. So the voltage is not going to vary. So even for the ideal current source, the current will remains constant throughout the time. It does not have any internal sources. Does not have any internal resistance. So there is no voltage drop across. So other one is called as a practical sources. Another one we have the practical sources. So where we have the voltage source. So there is an internal source resistance is there. That source resistance we are going to denote something called RS. This is the voltage, the RS, Vs. So if you draw the graph of the as the time goes, the voltage gradually will reduce across the source here. So this is for the practical voltage source. So similarly, the same thing happens for the current source also. For the current source, the source resistance is connected in parallelly across this one. So this is RS and this is the current which is called as IS here. So even for the current source also the same thing will happen. Gradually it will reduces as the time goes. So this is the difference between the practical and the ideal sources. So with this concept in the next session, let us look into the source transformations, how we can transform